Hello friends, this is Mathematical Physics Paper C5 2025 third semester CBCS. Okay, many students requested me to solve this paper as they have backlogs. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. Okay, if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. So choose the correct answer. This is the first question. To satisfy the result conditions, a function should be single valued and bounded. That is correct. Piecewise continuous, that is also correct. A finite number of extrema, that is also correct. So we can say all of the above. Okay, so answer is number 4, all of the above. Okay, so what is the next question? So let me go to the next question. Okay, so answer to this first one is the option 4, all of the above. So here you see the value of this integral. What is the integral? If you can't see that, let me write here. Minus infinity to plus infinity, integration from minus infinity to plus infinity minus alpha square hm of x hn of x dx. That is the integral. So here on and one more condition is given, m is equal to n, right? And value of this integral is given by this. Now let me. Its value is actually given by 2 to the power n, n factorial root over pi del mn. Okay, and for m is equal to n, del mn is equal to, this delta mn is equal to 1. Okay, for m is equal to n. For m not equal to n, it is 0, right? So delta mn is equal to 1 for m is equal to n, and in that case if you put here 1, then your answer will be 2 to the power n factorial n root over pi. That means the correct option is this, option number 4, right? Hope you have understood this. Now let me take this next question. Okay, so now let me clean these things, okay, so that I can show you the next one. Here you see, so here you see ln of x is equal to e to the power x nth order derivative with respect to x, nth order derivative of x to the power n e to the power minus x. We need to find L1 of x. So here you see it is very easy. Formula is already given in the question. Just you need to put n is equal to 1. And if you put n is equal to 1, then what you're going to have? Then you're going to have e to the power x. Then you're going to have first order derivative instead of nth order. Then x to the power 1 means simply x, e to the power minus x. Right? So now, if you see what we're going to have here, e to the power x, simply e to the power x. Now you apply u into v root. Okay, first function derivative of second function e to the power minus x, then plus second function which is e to the power minus x, derivative of the first function is x, right? So now e to the power x, then x into e to the power minus x, its derivative gonna be equal to minus 1 into e to the power minus x, and here e to the power x and derivative of x is simply 1, right? So we can take e to the power minus x common, or simply you can open this bracket, then x into minus 1, that's going to be minus x, and into the power e to the power x and e to the power minus x, if you multiply these two, you're going to have e to the power 0, which means equal to 1, then plus again e to the power plus x into e to the power minus x, that's going to be again 1. So we have got minus x plus 1, that means you can say 1 minus x. So which one is the correct option here? Option number 2, 1 minus x is the correct option. Now next question is on error function, right? So ERF infinity. So error function of infinity is always equal to 1. So remember this formula. Okay, so correct option is 2. This is the correct answer. Okay, next we have this. Next question we have z is equal to del u and v del x comma y, and zs is equal to del x comma y del u comma v, right? What we need to find? zs, right? So it is clearly it is seen that this one is inverse of this one, so definitely it's going to be equal to 1, right? So this fourth option is correct, right? So now let me take the next question. So here now question number 2a. Okay, now here you see question number 2b. This is already solved. Okay, I have already uploaded a video on this question where I have solved this question. Okay, link is in the description box. So and these two questions will be solved in the next video. Okay, and let me show you. And I also have solved this question number 3a. Link is in the description box. Also I have solved this differential equation. This is Bessel's differential equation. So that is also in the description box. I haven't solved this one yet. Okay, I will make a separate video on this. Okay, then I will provide the link in the next video. Okay, so let me tell you now what are the questions from this page I have already solved. So question number 3c, I have already proved all the recurrence formula of Legendre polynomial. Okay, Pn of x. Here only we need to prove 2. I have already proved all the 6 formulae. Okay, link is in the description box, and I have already proved this one as well in the beta and gamma function series. Okay, so in the description box I have written question number 2b answer, then I have provided the link, and similarly 3a, then similarly 3b1. Okay, then 3c, and question number 4. Okay, question number 4 I have provided the link in the description box. What's those videos for these answers, and those questions which are not solved yet will be solved in the next video. Okay, so thank you for watching. See you in the next video. Bye bye.